Welcome to Module 7. We've learned about demand and we've learned about supply. In Module 7, we're going to put them both together. And we're going to have to differentiate between what situations affect demand, what situations affect supply, and then how will that change the equilibrium price and the equilibrium quantity. So first of all, we're going to look at some differences between supply and demand. Competition is something that can affect both supply and demand, but it has an opposite effect on each. So if there's competition among consumers, that means that a lot of people are fighting over something that is scarce, that's rare, or limited. If everyone's fighting over something, so you can see an auction where several buyers are fighting for a rare good, or maybe it's a brand new technology that's very limited, or it's the Christmas toy that everybody wants. Well, anytime there's a limited amount of the good, and that leads to competition among consumers, that's going to drive the price up. Now, does that sound like something that will affect supply, or is that a demand effect? Okay, the answer is it's demand, and how you know is that demand is always from the consumer standpoint. So if everybody's fighting over that new technology, you might have a limited amount of that, and maybe somebody will buy extras and put it on eBay, and people will pay more for it. This is also true for maybe concert tickets. There's a limited amount of concert tickets available, so because people are competing over this scarce good, the people that could not buy them are going to pay more if they buy those tickets on StubHub or some other place. So that's going to be a demand effect. Now, if you have competition among producers of a good, that means that there's lots of companies that are going to get involved in producing goods. Now, this is actually great for consumers because you not only have more choices, but if there's multiple producers competing, that's going to improve the quality of the good, because if a certain brand has very poor quality, you'll choose to shop elsewhere. Also, that competition will lower prices because whichever is the most expensive supplier, people won't buy it from them. And therefore, the overall market will push prices down. Now, does that sound like, if it's about producers and people selling, firms, what does that sound like? Supply or demand? That's going to be a supply effect. Now, price is something that affects supply and demand. So first we're going to see how, if the price of oil increased, how that would affect each. Now, demand is about consumers. So if oil cost more, would you demand more or less of it? You demand less of it. So rising oil prices give an incentive for consumers to either drive less, so maybe they're going to carpool or take public transportation, just choose a method that they're going to consume less oil, or buy more efficient cars. So maybe they'll switch their consumption to another product like a hybrid or an electric car because they don't want to pay those high oil prices. So everything in purple, because it's about consumers, it's going to show how this price change affects demand. Now, the next part, the green section, is talking about producers. That will be about supply. If your company supplies oil and oil prices are going up, do you want to supply more or less? You want to supply more. Suppliers get paid those higher prices. So if the price of the product they're selling is on the rise, they want to sell more and more and more. So maybe they will try to increase the amount of places that they're drilling for oil in order to increase their supply. Before we get too far on this slide, I want to point out the fact that occasionally the note guides that you have will not be verbatim from the notes. So in this case, you can see that both of these bullets do answer the questions in the note guide, that you'll just have to slightly reorder your answer to make it fit. Just putting that out there. Okay, so Once you put supply and demand together, this can show economists quite a bit. It shows them where supply and demand intersect. That's going to be the equilibrium. So you can see the big equilibrium point here. Once we know the equilibrium, that will tell us at that price, equilibrium price, so in this case $3, what is the quantity that will be demanded and supplied? So it is 5. So that means that suppliers would love to supply more for a higher price, and consumers that control demand would love to buy more at a lower price. But where they meet in the middle is the equilibrium, and that will tell us the price the market thinks is fair, equilibrium price, and the quantity that the suppliers will agree to produce, and the consumers will agree to demand or purchase at equilibrium. Oftentimes, notes that are in italics are not things that you're going to have to write directly into Note Guide, and this slide is an example of that. This will just help give you a deeper explanation of equilibrium and how it works. So at equilibrium, the quantity supplied equals the quantity demanded. That's just another fancier way of explaining how they intersect. Now, the other key point here is that if you're in equilibrium, no individual consumer or producer would be better off doing something different. So you can look at this and see what the equilibrium price is. It is $3 here. And you know that because you can see where equilibrium is. And if you trace that E over to the price axis, you can see it's $3. Now, what if your store decided that you want to sell the good for $7 instead of $3? You can, that's possible. So what you do is you just trace out, doing this as straight as possible here. Okay, so at $7, that store would love to sell a ton of the product at a higher price. So their desire to supply is here. They would love to supply 7 units at that price. But do consumers want to pay the higher price? Probably not. So demand tells you what consumers want. At that $7 price, demand, you follow that down, is more like 2.5. So if the store decides to sell at the higher price, they will sell some. But instead of selling 5 units, they'll only sell 2.5. So some stores might decide that's worth it. They want to be a fine dining establishment. They want to be a high price designer, and they might be okay selling a far smaller number for a higher price. But they're definitely going to sell a lot less than they would if they were at equilibrium. So that's an example of how the producers would not be better off. Now let's see how consumers would not be better off. So again, equilibrium price is $3. If someone decided to, no, that's way too high, I refuse to spend that much money, I'm only going to spend $1. Okay, you might demand a huge number at $1. But stores aren't going to sell that much. Why would they produce a large amount of something at a very cheap price? So at $1, stores, and there might be some stores that are desperate, that are going out of business, that have low quality goods that'll sell you the product, but it's closer to 2. So if you insist on paying the lower price, there'll be some goods available, but far fewer goods that wouldn't be available at equilibrium. So that'll create a shortage, and it'll be very hard to find enough of the good at the lower price. So everything equals out at the equilibrium. The price that stores want to pay, or want you to pay for the good, is equal to the price that consumers feel is fair. And that will show you the quantity that is sold at that price. We're going to keep practicing this. I'm just trying to introduce how this rule that no individual would be better off doing something different. They might be able to buy or supply a small amount at a price that's not at equilibrium, but they're not going to get as much as if they went ahead and went along with the equilibrium that the market had set. So once you've found equilibrium, where supply intersects with demand, that will give you some other information. First, it will show you the equilibrium price. This is sometimes called the market clearing price. We'll talk about that in a minute. And it will also show you the equilibrium quantity. Now the question asks, why does the equilibrium price clear the market? So think of the market as all of the available stores that want to sell this product. At the equilibrium price, every buyer who's willing to pay that price will find a seller who's willing to sell it to them. So that will clear the market. Because supply equals demand, the quantity that stores are supplying will equal the quantity that customers are demanding. So everything that is produced and put in the market at that price will be sold, and that clears the market. If the price is too high, you're going to have all kinds of goods left over that people don't want to buy. If the price is too low, it actually will end up clearing the market too fast, and the price is going to be affected. We'll see how that works a little bit later in these notes. Idea being, once you have perfect equilibrium, that is the market clearing price, because every unit that is produced or supplied is sold. Every economic model comes with assumptions. We have to make certain assumptions to simplify the economy down into a way that we can actually graph it and study it, because it's way too complicated otherwise. So the assumption for finding equilibrium in a simple supply and demands model is that the market price has to be for a product where the market is well established and ongoing. That means that this has to be a product that's been for sale a long time. So there's probably certain things that you've bought before. You know approximately how much you think a latte should cost, or how much a cheeseburger should cost, or how much a pair of jeans should cost. And you probably have a relatively clear expectation of what you think is a fair price. Because these aren't new products, both the buyers and the sellers kind of agree on what's fair. If all of a sudden you saw that one banana was going for $9, that would seem kind of ridiculous, and you probably would not pay that price. That price is way too high. It's not going to clear the market. But if you saw that a Starbucks latte was going for 25 cents, you would think to yourself, wow, that's a super low price. I have an expectation that that's going to cost a lot more. And because this is much cheaper than I thought, I'm going to buy a lot of them. And in that case, sellers are the ones that are in trouble, because they are not going to have enough supplied to keep up with that. So brand new products, especially brand new technologies and inventions, are not well established and ongoing. So the very, very first smartphone, the very first tablet computer, people didn't have a sense of what a established price is going to be, because it's a brand new good. So often those things come at a much, much higher price at first. And then as the market becomes more well established, the prices start to settle out, and then you're going to reach this market clearing price. So here you have a new supply and demand. This model is for what good? You always want to label the good on top. And we normally label it on top, but this one, the good is actually labeled on the axes. So it says price of coffee beans, quantity of coffee beans. So you can tell there it's been labeled, just in a different place. So I want you to go ahead and try to answer those 3 questions in italics on your own. So please pause the video, and then we'll check over the answers in a moment. Okay, so the first question was, what is the equilibrium quantity? So you take equilibrium and then trace it down to the quantity axes. Now I hope you didn't write 10. It is 10 billion pounds. That's important. So make sure that you're reading these axes. 10 and 10 billion are different things. So if you just have 10, please go ahead and add billion pounds to the end of it. Okay, the next question is about the equilibrium price. So here you're taking equilibrium, tracing it over to the price axis, and we have $1 per pound. Now you can see you can see per pound here, and the reason I know dollar is that it's on this one. So I'm kind of trying to show you all the little clues that you use to figure these things out. So the equilibrium price is $1 per pound. So if the price is $1 and consumers decide, if producers decide to charge $1.50 per pound of coffee, what sort of problems could they run into? Well, they're at $1.50. I'm going to show you by tracing this over to the best of my ability here. So supply is greater than demand at $1.50. And that should be no surprise to you that at a higher price, producers are going to want to supply a lot of it. And there are some people that will pay more money for their coffee beans, so there will be some demand, but it will be less. If supply is greater than demand, you're going to have a surplus. So anytime a producer is trying to charge a higher price than the equilibrium price, that's going to create a surplus. So surplus is always a higher price than equilibrium. Now, this is sometimes called excess supply because, as you can see, at a price above equilibrium, supply is greater than demand. Now, we're going to actually learn how to calculate this mathematically. So there will be an equation here for calculating, well, how big is the surplus? So I have this written out two ways. The first way is kind of a word equation. So this just says surplus is calculated by subtracting the quantity demanded at that price from the quantity supplied at that price. In the rectangle, that's where I want you to put equations in your notes. So you can always refer back to them when you're studying. So the surplus equation is QS, which stands for quantity supplied, minus QD, which stands for quantity demanded. So in this table, we can look and see, well, what is the quantity supplied at $1.50? So $1.50, you trace that line across where it hits supply, is the quantity supplied. So that is 11.2. Minus the quantity demanded. So at that price, the quantity demanded over here is 8.1. Now, no calculators. You're expected to do some light decimal work. So what is 11.2 minus 8.1? Your answer is going to be 3.1. I think that goes a little bit later. In your notes, there's an italics question that asks about what size is the surplus at $1.50, but that's how you find it. Also, just to preview what's coming on the next slide, if you have a surplus, you have too much of something. So think about stores that you shop at. If there's a ton of t-shirts and they've supplied way more than people are demanding, what normally happens to that good? It normally goes on sale. So whenever there's a surplus, it's because the price is too high. It's higher than equilibrium. So the solution to a surplus is going to be to lower the prices, and we'll see how that works on the next slide. So in a surplus, producers cannot find enough buyers for their excess goods. They've produced more that is being demanded at that price. So whenever you have too much of something, the solution in order to clear the market is to lower the price. If there's too much of a good, you have to lower the price. So if we started off at $1.50, maybe these stores are going to be conservative and they want to lower the price at first to $1.25 because there's no magic thing that tells coffee producers your equilibrium price is $1. They don't know that. So if they're just doing trial and error, maybe they'll lower the price a quarter. Now at that price, at $1.25, are things better? Yeah. other than my wobbly line here, the difference between supply and demand is smaller. There's still a gap, but it's getting better. So a smaller surplus at that price. And then they're going to lower the price a little bit more to get rid of that remaining difference between supply and demand. And now all of a sudden they've hit this market clearing price where everything that they are producing is actually getting purchased. That's how they know they've reached equilibrium. So the prices get lowered, lowered, lowered until they hit equilibrium. That's going to clear the market. So the first italics question you have is just another kind of review question. What is the equilibrium price for coffee beans? So looking at this picture, it is $1 per pound. Now we already answered this last question when we were doing the equation before. For surplus, the equation is quantity supplied, so 11.2, minus quantity demanded, 8.1. So if you recall, the amount of that surplus is 3.1. Now to be clear, it's 3.1 billion pounds. So make sure that you have the exact number. 3.1 billion pounds is a lot of coffee to have sitting around. So you can see how producers would have an incentive to lower price to get rid of that huge amount of excess supply. Here we have another example of supply and demand, in this case for pencils. Go ahead and answer these questions on your own. Pause the video, and then we'll go over the right answers when you're done. Okay, what is the equilibrium price for pencils? So you just see where supply meets demand is our equilibrium. You trace that over to the price axis. So the equilibrium price is 3, and we know it's in dollars, so $3. Then the next question is, what is the excess supply of pencils if they're sold at $7? So $7 is clearly substantially more than the equilibrium price. So you take $7 across, and where it hits supply is the quantity supplied, 7. And our equation is quantity supplied minus quantity demanded. So the quantity demanded is where demand hits $7 is 2.5. So 7 minus 2.5 equals 4.5. So that's going to be the size of our surplus. Now, what should pencil suppliers do to sell their excess pencils? If they were selling them for $7 and they're realizing that people really aren't buying a lot of pencils at that price, what are they going to do? They will lower the price. And as they lower the price, you can see that the gap between supply and demand gets smaller, 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 until they hit the right price, until they come across this market clearing price where all of the pencils that they produce are sold. Now they've hit equilibrium. We've learned about surpluses. The next example is a shortage. Anytime the price is too low, if it's lower than equilibrium, consumers are really, really happy. They love low prices, so they're going to demand a lot. That's why a shortage is often called excess demand, because they demand more than producers want to supply at that low price. So there's 2 ways to figure out this equation. The word problem says the shortage is calculated by subtracting the quantity supplied at that price from the quantity demanded at that price. Or we have it written out in our box, shortage equals QD, quantity demanded, minus QS, quantity supplied. Now you might get confused, well, wait a minute, which equation is QS minus QD and which one's QD minus QS? Well, the answer is you're never going to have a negative answer. You're going to have a positive surplus or a positive shortage. So if you're setting up your equation and you got a negative answer, you set it up backwards. Now we can look here at our shortage. So the equilibrium price is $1. at 75 cents, we have a shortage where demand exceeds supply. So following that line across, whoa, got a little crazy there. Following that line across, that's better. The quantity demanded is 11.5. The quantity supplied at 75 cents is 9.1. So the size of the shortage is, think about it, 2.4. And of course, it's 2.4 billion pounds. That's very important. So what that tells you is that consumers would love to pay a lower price for coffee. But if they do, there won't be enough coffee to meet that demand. 2.4 billion people that wanted to buy a pound of coffee won't be able to because it wasn't produced. Because stores and firms did not find it worthwhile to produce it at that lower price. Maybe they wouldn't make enough profit. So shortages, we like low prices, but it does create problems in the economy. So in a surplus, prices were too high, and so the firms had to lower the price. Now in this case, there's a shortage. There's not enough of the good. You might have seen a situation where something was scarce and people start fighting over it. If you're a store owner and you see people lining up or fighting over the last of a certain good, what would you do to its price? You're probably going to raise the price. So in either problem, in a shortage or a surplus, the result will be that the price is going to naturally correct itself by moving back to the equilibrium price. So consumers who really, really want coffee, think of all those people that weren't able to get it. They might have happily paid a quarter more per pound in order to actually have some coffee. So if they're willing to pay more, then the price can rise up to the equilibrium price, which will clear the market. So hopefully this is all sinking in by now. But remember, to calculate the size of the shortage, you just take the bigger number here, the quantity demanded, so 11.5, and you subtract the quantity supplied. So the size of the shortage is, remember, 2.4 billion pounds. If coffee producers realize that a lot of people want to buy their product, they will respond to the shortage by doing what to the price? If they raise the price, they now have, maybe they're selling a little bit less coffee than they would, but the idea was they weren't actually selling this 11.5 before they hadn't produced enough. So they're actually selling more at the higher price. So they were only supplying 9.1 before, but when they raise the price, now they're going to sell 10 billion pounds. So it's in their best interest, and the market has responded and reached the new equilibrium. Now I'd like you to practice figuring out surpluses and shortages with supply and demand. First of all, before you start answering these questions, look at your picture, your supply and demand model on your notes. What is it missing? You have the price quantity, the price axis labeled, you have the quantity axis labeled, you have supply, you have demand, but the one in your notes is missing the name of the good. So please go ahead and write in soda, because we know that this model is about soda, and you can't have a supply and demand model without labeling supply and demand of what. So go ahead, please pause the video, answer 1 through 4 on your own, then we can restart and go over the correct answers. Okay, so we're going to have our equilibrium, where supply and demand meet. Your model also didn't have equilibrium labeled, so go ahead and write that in too, please. So what is the equilibrium price? So we take this E and we follow it over. So the equilibrium price for soda is $3. The equilibrium quantity for soda, you follow equilibrium down to the quantity axis, it is 150. So that's the market clearing price of $3. The market will sell 150 sodas. Now, let's see what would happen if stores wanted to sell $4. So what you should do is maybe draw a dotted line or draw a line in pencil just to see kind of how this works. So at $4, is there a surplus or a shortage? How you know this is what's bigger. At $4, is supply bigger or demand bigger? Supply is bigger. So if there's more supply than demand, excess supply means you have a surplus. You have too much. How big is it? So what you do is at that price, you see what is the size of the quantity supplied, 200, minus what is the size of the quantity demanded, 100, so how big is your surplus? It is 100. So that's a pretty big gap. That stores rather want to supply 200, but consumers only want to buy 100. So the price is wrong in some way. So what do? How does the market adapt to this surplus? What will firms do to the price? They're going to lower the price. Now, at the $3, the equilibrium price, before, demand is how much is actually being bought. So even though stores want to supply 200, nobody's buying those. Only 100 were purchased before. So at the new price of $3, 150 are actually being purchased. So stores are better off because they're able to sell more. And customers are better off because they're actually getting this for a cheaper price, $3 instead of $4. So remember, at equilibrium, nobody is better off doing anything else. Let's do the next one, $1 per soda. And if you messed up the $4 one, go ahead and pause this again and redo your work just to check. But I'm going to keep going with the $1 per soda. Okay, so you trace out at $1 per soda. Now, what's bigger, supply or demand? Here's our supply, where it meets. Here's our demand. So the demand is bigger. If you have more demand, you have a shortage. What is the size of that shortage? So quantity demanded, 250. Minus quantity supplied, 50. Equals 200. So that's a pretty big shortage. So sodas are so cheap that consumers would love to only pay $1, but stores are not okay with that. So the amount that is actually bought is 50. People might want to buy 250, but stores aren't willing to make them. So how will the market adapt? Firms will do what to the price of soda? Going to increase the price. If they increase it to $2, then they've made the shortage smaller. At $2, the gap's only 100, but it still isn't a market clearing price. Once they raise the price to $3, you're going to have a market clearing price. And before, they were only selling 50 sodas. Now they're going to sell 150. So stores are better off because they're going to sell more. Now you might say, well, consumers aren't better off. They're paying more money. But 100 people are now getting access to a product than were before. And if they weren't willing to pay the price, they wouldn't pay it. So they're at least satisfied with the equilibrium price. So hopefully at this point, you feel a lot more confident with identifying if you have a surplus or shortage, and figuring out the size of it and then what to do to solve the problem. So we've learned what affects supply, what affects demand. We just learned about problems that arise when you're not on equilibrium, if you have a surplus or a shortage. And now we're going to see what happens when one of the lines shifts and equilibrium actually moves. So in the example on the left here, both of these are about coffee because it tells us on the axes these are about coffee or coffee beans. But what is happening on the one on the left? What line is shifting? Okay, demand is shifting. Now, is demand increasing or decreasing? If it's a right shift, that means demand increased. Now let's practice some of our words here because this can be really confusing for people. Demand increased, but what happened to supply? The answer is nothing. Okay, if it's a move along the curve, we say the quantity changed in some way. So what happened to the quantity supplied? It was here, and now it was here. So it moved along to the right. Right is always an increase. So the answer here is the demand increased and the quantity supplied increased. Now let's practice on the right. What line shifted here? Okay, supply shifted. And it shifted to the left, which tells you that supply decreased. Now what happened to demand? It's on the same curve, so you're going to say the quantity demanded. Now remember, there is no up. So saying it went up, that is not the right answer. It went to the left. See how it was here and it moved to the left? And left is a decrease. This is why we've been talking about left and right. So the answer is supply decreased and the quantity demanded decreased. This is tricky. We're going to keep working with this. First, we're going to practice with demand shifters. In this first situation, tea is a blank for coffee. Your options are, is tea a complementary good or a substitute good? Remember those words before? Complementary goods are and, you buy them together. Substitute goods are or, you buy one instead of the other. So in this case, tea is a substitute for coffee. If the price of tea rises, what would happen to the demand for coffee? So you could buy coffee or tea, they're substitutes, but now tea costs more. So which one do you want to buy? You want to buy coffee, so the demand for coffee will increase. So we have it here, we can see the demand increasing. After that demand shift, what happened to the price? So the price was here, we have our equilibrium 1, which lines up with our P1 and quantity 1. When demand shifts, when it shifts to the right, we're going to have an E2, a P2, and a Q2. That's showing you all the new equilibrium prices, equilibrium quantities. So when we had the shift, the price went from here to here. The price increased. FYI, you can always do up arrows in your notes. You don't have to write increased. That's fine with me. Now, what happened to the quantity demanded at E2 compared to E1? So remember, on these models, this is always a 0. So your quantity went from here over to the right. Right is an increase. You can also look at it in terms of it's further away from 0. So either way, it increased. Now let's think about this logically. Does this make sense? If you could buy tea or coffee and now tea costs more, people are going to want to buy more coffee. If people are going to want to buy more coffee, that makes sense that the quantity of it will go up. But the price of it's going to go up too. Things that are more popular are going to have a spike in their price. So let's go ahead and start doing some practice questions. The hint here is that all of these are going to be about demand. They're going to be demand shifters. But when you're setting this up, you always have supply and demand. Where they meet is the equilibrium. You need the price axis always on this side. Quantity axis always on this side. The equilibrium where it hits the quantity. Equilibrium where it hits the price. And then the name of the good. In this case, it's about concert tickets. I'm just writing tickets because it's very slow to write anything with my cursor when I make these videos here for you. All right, there we go, tickets. So this one says, as a band gains more success and becomes more popular with fans, what happens to the price and quantity of concert tickets sold? So you're going to need to think about how this affects demand. Does it increase it? Does it decrease it? Those are both shifts. Or is it a move along the curve for demand? So let's review what the demand shifters are. Whatever one you pick, you're going to have to say which one it was. So our acronym for demand shifters were MERIT. We had MERIT. Now, while I'm running this, think about which of any of these you remember. What does M stand for, E, and so on? Okay, M is market size. This is the number of consumers. How many people want to buy that good? E is expectations. Expectations is always about, do you expect the price to change in the future? R is related goods or prices. That's the complementary or substitute goods. So our example with tea and coffee, that was part of related goods / substitutes would be the shifter for that question. I is about income. So income also has two categories. There are normal goods. Those are things that you buy when you have money. And then inferior goods. Those are things that you demand more of when your incomes fall. And then finally, T stands for taste. That's the popularity or the trendiness of the good. So go ahead and do both of these two questions. Pause the video. You want to practice drawing and labeling, identifying the shift, drawing and labeling the shift, and then also identifying what is the shifter. Why did that affect demand in that way? Then we'll go over these answers. Okay, I went ahead and drew these out on the computer because that's a lot cleaner than me drawing it with the cursor. So the first example we already kind of hinted at about tickets, and that one is taste. The reason? It's about popularity of the item. It's a lot more trendy and more popular. That's going to be a taste shift. Now, if you said market size, there are now more fans and more people in the market for that good, that would also be right. That's fine. Sometimes there's more than one possible right answer as long as you draw the correct shift and you can explain why it shifted. Great. So here we're saying that as something becomes more popular, the demand will increase. So we're drawing the demand line shifting to the right. So we have a D2, and you're always going to have an arrow showing the direction of the shift. So at all of these things, we have arrows and 2s. So we have Q and Q2 with an arrow, P and P2 with an arrow, and then E and E2. You don't have to have another arrow because the demand shift arrow functions for that one. So when we were practicing the words before, would you say, did demand increase or decrease, or did the quantity demanded increase or decrease? If the whole line shifted, you would just say that demand increased. Now, but what happened to supply? Supply had to move along the curve from E to E2. So the quantity of supply moved to the right, so the quantity of supply increased. Okay, hopefully that went all right. Now, and that also makes sense that as a band became more popular, maybe they'll open up a second tour date, so the quantity of tickets would increase. But also, if everybody wants those tickets, they're going to be sold for much higher prices, maybe at the gate or online. So prices are going to go up and quantity will go up too. The next example here says, during a recession, people buy fewer new cars. What happens to the price and quantity of new cars sold? So we have it labeled. You have price, quantity, supply, demand, equilibrium, where price hits equilibrium or quantity hits equilibrium. And you also need to have the good, so new car. Because if this was just car, that'd be a different situation. If it was used car, you might have a different shift. Because remember, new cars are normal goods, but used cars are inferior goods. So you want to label it new cars because that's important to the question. And that's kind of my hint to what's the shifter. New cars are normal goods. It costs a lot of money, and you're only going to buy a brand new car if your income is higher, if the economy is doing better. So as income levels increase, your demand for that good goes up. But here we have a recession. So income levels are falling. And because new cars are normal goods, you're going to demand fewer of them in a recession. So the demand shifts to the left. We have D2 and an arrow. We have an E2, Q2 and an arrow, and P2 and an arrow. So you're going to demand fewer, which means that the quantity of new cars that are sold will decrease. But also, if people really aren't buying goods, then those car lots are going to have to put those cars on sale. They're going to have more cars to sell at those end of year clearance events that they do. So this makes sense in the real world. When the demand decreases, the quantity and the price will decrease as well. Now that you've practiced a few situations where demand shifted, we can get to the economic principle, kind of the rule about what happens in markets when demand shifts. So if demand increases, the equilibrium price increases and the equilibrium quantity increases. So demand is always easier than supply. It's easier because we're consumers and so you can relate to demand. But it's also easier because everything goes in the same direction. When demand increases, the price increases, the quantity increases. People want more of something and they're willing to pay more for it. When demand decreases, the price will decrease and the quantity will decrease. Everything goes up together or everything goes down together. And even this one makes sense too. If something is less popular, people are going to demand less of it, and they want to pay less for it. So all of these things line up for demand. Next, we'll practice supply. Supply isn't going to be quite so perfect, and things will not all go up and down together. Next, let's practice some supply shifters. So for supply, we have RICEist. We'll review what that acronym all stands for on the next slide. So quality growing land is a blank for coffee. Hint, it's something that you need that can help you produce that good that goes into making the good. This is an input. So quality growing land is an input for coffee. Need it to produce the good. If quality growing land became more expensive, what would happen to the supply for coffee? Do you think that producers are going to supply more or less if an input price goes up? They're going to supply less. So we had a left shift in supply. So when we went from E to E2, what happened to the price? Look at your P1 and your P2. It went up. It increased. Which again is kind of intuitive, that if it costs more for producers to produce the good because the inputs cost more, that's going to make the price of the good go up. Now, if something is cutting into their profit, like a higher priced input, what's going to happen to the quantity? So from Q1 to Q2, we have a left shift. We're getting closer to zero, so the quantity decreases. So the price will go up, but the quantity will go down. We'll practice some more examples on the next slide. Okay, so all of these examples here are going to be about supply shifts. I'm going to go ahead and start doing my long acronym here for RISIST. As I'm writing, start thinking about, do you remember what any of these letters of supply shifters stand for? Little review. Okay, R is for related goods or prices. R is the same on both supply and demand because supply has related goods as well. So at your factory, you can supply complementary goods, which means you're producing both. Complements are always and. Or substitute goods. You could produce at your factory this or that. That would be related goods dash substitutes. Now, I is different. I, in this case, is going to be input, like we saw on the last example. These are the resources that go into producing the products. C stands for competition. This is the number of producers. If more companies are supplying that good, the supply will increase. If there are fewer people supplying the good, fewer competitors, then the supply will decrease. E is the same for supply and demand, expectations, because remember, stores expect price changes too. They're going to respond to that game in a different way, but they're also expecting price changes in the future. S stands for subsidies and taxes. This is the government category. If government gives subsidies, then the supply will increase. They're getting paid to produce it. They want to produce more. If government gives taxes on that good, the supply will decrease because now it cuts into the profit. It costs them more and they will supply less. T stands for technology. If you have more technology, you can produce more of the good. Supply increases. If there's a technology shortage, you would be able to produce less. The supply would decrease. All right, so all of that, RISIS, that was a review for what you're going to put for these shifters here. Remember, you always label price, quantity, the supply line, demand, equilibrium, equilibrium price, equilibrium quantity, and the name of the good. So once you've sketched all of that out, read the questions, determine what will happen to supply, and draw that shift. Pause the video and we'll go over the right answers. In our first example, it says, cotton is an important raw material in the making of clothes like denim, jeans. If the global price of cotton rises, what happens to the price and quantity of jeans sold? So our good is jeans, not cotton. Just make sure that you're reading the question carefully. Now, cotton is an important raw material. It is an input in the production of jeans. If an input price goes up, the supply will decrease. So let's practice our words now that we know how to draw it. If supply decreased, what happened to demand? The quantity demanded did what? It shifted to the left. Remember, there is no up. So supply decreased, the quantity demanded decreased. Next one. Production technology has greatly improved in agriculture, producing more corn on the same amount of land. How has the better technology affected the price and quantity of corn sold? So our good is corn. The question makes it pretty clear that the shifter is technology. And you now can produce more, so the supply increase shifts to the right. Oh, I don't have demand label there for some reason. There we go. And let's practice our words. What happened to supply? Supply increased. And what happened to demand? The quantity demanded increased. It shifts to the right. We also should have a little arrow here. There we go. Perfect. At this this point, you've probably figured out that supply functions a little bit differently than demand. If supply increases, then the quantity increases too, which makes sense. There's more of it. You supplied more, so the quantity is higher. But the price falls. Now think about it this way. If something is very plentiful, there's a ton of something, supply went up, that means the price will go down. So this does make sense if you think it through, but it's not as simple as everything's up, everything's down. Now, if the supply decreases, the quantity will decrease too. You supplied less, there is less. Now, if something is now more rare, the price of it will go up. So, some things go up, some things go down in supply. You can either think it through, or you can just sketch it out really quickly to determine which things are increasing or decreasing when it's a supply shift. So we have done situations where demand shifted and different examples where supply shifted. Now things are about to get a little bit more complicated because now we're going to have both shift. This is where it gets hard. If both supply and demand shift, the amount they shift matters. Let me show you what I mean. In this picture, we have supply shifting left and supply shifting left. Here, so that should be the same, right? Here we have demand shifting right and demand shifting right. So it might look like the exact same thing happening in each situation. But the one on the left, demand increased more. The one on the right, supply increased more. And that's going to matter because look at both of them. Our E1 is where our first supply meets our first demand. Our E2 is where supply 2 equals demand 2. So we can tell from E1 to E2, price went up on both, E1 to E2. But quantity is not the same. Here, where demand increased, our quantity increased. The other one where supply increased more, quantity will actually decrease. So that's an uh-oh. It's not going to be okay to draw one and have one answer and draw the other one and have the other answer. So I'm going to show you a trick to figure out what the right answer is, but I just want you to see that the amount of which one shifted more is going to impact the answer. So be very aware of how that's going to work. Whenever there is a double shift, meaning both supply and demand shift, there will be something that we know for sure and something that we don't. Now the first example will be shifts in opposite directions. So the example is here in the bottom in orange. It says a decrease in the demand for rap music coupled with an increase in rap artists. So here I have two different supply and demand models because one of them will have, we're going to draw demand having a bigger shift, and the other one we're going to draw supply having a bigger shift. And we're going to see which one has the biggest effect. So here, everything is drawn out. Now it says a decrease in the demand for rap music. So both of them we have demand shifting left. On the first one, it only shifted a little bit. On the second one, it decreased a lot. And an increase in rap artists. That's going to be about supply. So the first one we have supply increasing a lot. Second one we have supply increasing a little bit. Now, where your S2 and your D2 meet is going to be E2. So we can see in both of them, in the left and the right example, price went down, price went down. And that is why, if the shifts are in opposite directions, we know price for sure. And what that means, opposite directions, do you see how supply increased and demand decreased? That's a shift in the opposite direction. So price, we can tell. We can tell that when supply increases and demand decreases, the price will decrease. Now, what happened to quantity? In the first example, when supply had the biggest effect, quantity increases. See that here? But in the one where demand had the biggest effect, quantity decreased. So wait a minute. We know that price fell, but did quantity increase or did quantity decrease? We don't actually know. And that's why it's important not just to draw these models randomly with supply and demand shifting an unknown amount. So we're going to see, well, how do you draw it so you know what information you know for sure? So here is the trick. Whenever there's a double shift, what you have to do is evenly space the lines. So you can see that in the first one, the amount that we drew supply shifting is pretty much the same as the amount of the demand shift. So in this case, supply shifted right. So supply increased and demand shifted left. So demand decreased. So you can tell that this is a shift in the opposite direction. And when we space them evenly, we can tell, oh, price definitely fell. No question. But what happened to quantity? E and E2, when you space them out, they have pretty much the same quantity. We don't know if it went up, if it went down. So you still want to draw a Q2. You can't leave that out because wherever S2 meets D2 is going to be an E2. And the equilibrium 2 needs to have a P2 and a Q2. So you do have to draw it, but you draw it below the original quantity. And if I asked you a word problem, you would say that the price decreased, but the quantity is unknown. Now, never say it didn't change, because yes, it did. We saw in the last one, maybe it increased, maybe it decreased. We're just not sure. And there's a big difference between saying it didn't change versus the change is unknown. Do you get what I'm saying? In this example on the right, we have supply shifting left, so supply decreased, and demand shifting right, so demand increased. So here's an example of a double shift in the opposite direction. One went up, the other one went down. But when you draw them evenly spaced, we can tell that price definitely went up. But we don't know what happened to quantity. So for this double shift, you would say that the price increased, but the effect on quantity is unknown. So I hope in the box in your notes, you drew that double shift with the lines evenly spaced, because that's the proper way to do it. And that's how you can actually tell what do we know for sure and what do we not. So those were both shifts in opposite directions, where maybe supply increased and demand decreased. Now let's see what happens when there's a double shift in the same direction. So here in our situation, it says a decrease in demand for disco music and a decrease in disco artists. So both the demand and the supply will decrease. But we're not going to know which one decreases more. If it's a shift in the same direction, quantity we will know for sure, but price is going to be the question mark. So we're going to see, just like before, how you look at it if you draw one bigger than the other, and then how you properly draw this shift. So here we have the double shift in the same direction, where there was a decrease in demand for disco music and a decrease in disco artists, which is the supply shifter. So in both of these examples, the one on the left, supply decreased more, and the one on the right, demand decreased more. So both of them have both lines decreasing, and in both situations, the quantity is definitely decreasing too. Left shift of quantity. So when it's a shift in the same direction, we can absolutely tell what's happening to quantity. We don't know for sure what's happening to price. Because on the left, when the greater effect was a supply decrease, the price increased. But when the larger shift was the demand shift, the price decreased. So what happened to the price? That's the question mark. That's the thing we don't know for sure. So remember, I hope you're not drawing these in your notes. The proper way to draw it is to have the lines be evenly spaced. And that way you'll save yourself from having to draw it twice like this. Because what if you only drew it once? Then you would answer the question maybe like the question on the model on the left. And you would say, oh, for sure, quantity decreased, price increased. But that's not the right answer. And if you just drew it once, or if you only drew it with the lines uneven, you won't actually know what's truly happening in the model. So this is exactly how you draw a double shift in the same direction. The first example that we have, supply is shifting to the right, so supply increased, and demand is also shifting to the right, so demand increased. In this situation, we can tell for sure that quantity increased because E2, we know for sure that quantity did move to the right. But what happened to the price? We're not able to tell in this model. So you draw P and then P2 to the side next to it to demonstrate the fact that price could have increased, it could have decreased, it's unknown. And then on the left here, we have supply shifting left or decreasing, and demand shifting left or decreasing. And so again, it's in the same direction, so we know quantity for sure. In this case, quantity decreased, and price is the unknown determinant. It could have increased, it could have decreased. We have no way of knowing without knowing which line shifted more. Let's do one example of a double shift to practice. So this situation says, the recent Winter Olympics has increased the popularity of snowboarding and more companies have begun producing snowboards. How will these events affect the market for snowboards? So hopefully you can tell that you're drawing a supply and demand model for snowboards. That's a good that you'll label. And you're going to have price, quantity, supply, and demand. Before I show you the answer here, popularity of snowboards. Does that sound like a supply or demand shifter? That's going to be about demand. And then which category, which shifter would popularity of snowboarding be? Okay, that is taste. It is how popular something is. Taste. Okay, and then more companies have begun producing snowboards. So does that sound like that is affecting supply or demand? That is supply. And what category is the shifter there? More companies, that is competition, the number of competitors. Okay, I'm just going to leave that there. You know it's competition. Now, if more companies are producing snowboards, the supply will do what? Increase or decrease? It's going to be a supply increase. And then the popularity of snowboards has increased, so demand will also increase. So I'm going to make all those notes go away, and let's see how it looks. All right, so here we have supply increasing and demand increasing. Both of them shifted right. So the thing we can tell for sure is that quantity increased, and the effect on the price is unknown. So remember, whenever you're doing a double shift, it needs to be evenly spaced, and there will always be one thing, either price or quantity, that is unknown. If you think you have an answer to both, then you did something wrong.